Hey everyone, we've just seen the types of images that are created by lenses and mirrors. Now we're going to take a look at our first type of mirror, the plane mirror. This is also known as a flat mirror, what you look into every morning as you get ready for school. So if we just look at how the images are formed, you can see that if our object is point O right here, then the rays follow the law of reflection. That stated that the angle of incidence equals the angle of refraction. If you draw that normal to the surface here, you can see that this is the angle of incidence for this top ray here, and then the angle of reflection here is exactly the same. So all the rays follow the law of reflection, and they all are diverging as they reflect off the mirror. So your eyes project all of those rays backwards until they intersect, and that's where your image is going to be formed. So that's what we just saw in the previous video as well, that we have a virtual image. So what we want to look at is what are the properties of these images that are formed by these plane mirrors. We have another example here where instead of a dot for an object we have an arrow. That's our preference, is to use arrows because then it's easier to see if the image is upright or inverted. So if we just look at how this ray diagram was formed here, we have our object. We have a ray that is incident straight at the mirror, perpendicular to the mirror, so it's going to reflect along the same exact line. And then you have another ray here that is hitting this line here where the object was sitting on, and then it's reflecting at that same angle of reflection as the angle of incidence. So these two rays that are reflecting here off the mirror, they're diverging, so you trace them back. Where they intersect here is where the image is formed. And you could draw a lot more rays and they would still all intersect here. So the first thing that we notice is that the image distance is equal to the object distance. So the image distance is always from the mirror to where the image is formed, and that's equal to this object distance here. We're actually going to have different notation for these various distances. The next property is that the image is always the same size as the object. You can see here that because of this straight line here that is reflected back and then extended backwards, that the image will always have the same size as the object. The third property is that the image is always upright. When you look at yourself in a flat mirror, you're not going to be upside down. The last thing is that a flat mirror or plane mirror always produces a virtual image. The rays always diverge when reflecting from the mirror, and you always have to trace them back. This means that you cannot capture this image on a screen. But if you're looking at the mirror, then you can see the image inside the mirror. Here's the notation that we're going to be using throughout this chapter. So the first one is, how do we notate the distance between the mirror here and the object? And we're going to use a lowercase letter p here. What about the distance from the mirror to the image? That's going to be q. The object height is going to be h, and then the image height will be h prime. Those are the only letters that you have to worry about here. Let's do a couple of examples. This first one here, it says you're looking at the image of a pencil in a mirror. What do you see in the mirror if the top half is covered with a dark piece of paper? So I put some graph paper just because it helps me draw my lines more accurately, even though it's hard to draw a straight line, but it'll be a lot easier. So if we draw our pencil here, and then this is our mirror here, this line, let's just use this line here, and we're going to cover this top half of the mirror with some black paper. That means that the top half of the mirror is not going to reflect any of the rays. And our eye is going to be over here. We're going to be looking at the rays coming into our eyes. We learned earlier that that's how we see objects. So in order to see the full image of this pencil, then a ray from the top of the pencil and a ray from the bottom of the pencil, both of them have to be able to reach our eyes. So what we can do is we can look at a ray coming from the top of the pencil. Let's say that it's hitting the mirror at this location right here, right underneath where it's not covered up. then if it's incident this way, it's going to reflect according to the law of reflection, and it's going to reflect right this way, and it's going to go into our eyes. That means that when our eyes trace that rays backwards, or brains trace it backwards, then we'll see the top of the pencil right there, right? We just learned in the previous slides that the image distance is always the same as the object distance. And we learned that the image is always the same height. So we know the top of the pencil is going to be right here. Let's look at the bottom of the pencil. If we draw a ray, let's say going this way, and then reflecting the same angle, we can see that that one also reaches our eyes. So, and my line's not super straight, but if you trace it back, then you can see that the lead here is going to be formed right here, and all of the points in between could also be shown with other rays. So it turns out that we actually see the whole image of the pencil if we're right here and the top half is covered. I have another picture of this that shows this a little better, right? This is what I was trying to draw. But you might think, well, okay, then does this mean that we always see the whole object? But it's not the case, right? Let's say that the piece of paper was a little bit longer, right? More than half of the mirror here. Then what that means is that this ray here would definitely not reflect. So you'd have to have a ray going this way, right underneath the paper. But according to the law of reflection, that ray is going to reflect down here somewhere. And it's not going to reach our eyes. So we're not going to see the eraser of the pencil if the paper is too big. And in general, if you have one of those long mirrors in your dorm room, then you know that that mirror is not as big as you are, but you can see your whole body in it. As long as you put it in the correct position, at the correct height, you only need a mirror that is half of your length, and you'll be able to see your whole image in there. Let's do one more question. In this one, we have the object is placed right here, and the observer is over here. That's your eye. So where are we going to see the image? So what we can do is we can just trace a random ray that's going to reflect off of the mirror here. Let's say that we have a ray going this way. Then we know that it's going to reflect this way, approximately. And then we can trace it back. And that means that the tip of the tree here will be formed right here. We can do the same thing for the bottom. If it happens to hit here, it will reflect over here. And then we'll trace it back, and it will be formed right here. So the image will be formed right here. You actually didn't even have to draw the rays if you just remember the properties of the images formed by plane mirrors. The image here is always the same distance as the object from the mirror, and always the same height. So it's always going to be just on the other side of the mirror. That's it for this section. Let's look at curved mirrors next.